Hello everyone, welcome to our lecture on dynamic memory allocation. In this lecture, we are going to discuss how we can allocate memory for variables at the runtime. Implementation of 1D and 2D array dynamically means at the runtime. Now, dynamic memory allocation basically it means that creating a memory space to store some value at the runtime. Now, we already know that when we are declaring a variable in the program, space for that variable will be allocated at the time of compilation. When we are creating a space for a variable in the compilation time, we cannot modify its size. Now, dynamic memory allocation allow me to create a space to store some value at the time of execution, means at the runtime. When needed, we are going to create a space for a variable. Now, this will help us to use the computer memory in more efficient way than static memory allocation, that is at the time of compilation, because we are creating that much of amount of memory what is required at the time of runtime or when we are running the code. Now, if we want to change the allocated memory, that is also possible in dynamic memory allocation, which is not available in static memory allocation. So, creating an array which size have to be defined or declared at the time of compilation will take much more space than a dynamically created array. The reason is that suppose you have declared an array of 100 elements of integer type, suppose, so it will take by considering integer size is 4 byte, it will take 100 into 4, that is 400 byte of space. Now, if we are storing only 10 data into that array, means rest of the 360 byte is occupied but not in use. So it is not a very good memory utilization. Now, dynamic and memory allocation allow us to create an array or any memory unit in such a way that it can be created at the runtime depending on the number of data you want to store. So we will be able to create an array for 10 integers data only. So we are saving space. So it is much more memory efficient. Now we are going to discuss how we are going to use the feature of dynamic memory allocation in C language. So dynamic memory allocation, it can create memory space for the variable at runtime. It makes code more memory efficient because it is utilizing memory space when it is required, otherwise not. We have already explained that. Dynamically memory space can be freed, means when the utilization of this space is over, we can delete it from our main memory. So that amount of space is free now, right? And also we can increase or decrease the size of dynamically created space depending on the need. In C language, there are 4 library functions which are used for the dynamically memory allocation. That is calloc, malloc, realloc, and free. We are going to see all the 4 operations in details. These library functions are declared in stdlib.h header file. In Turbo C++ compiler, it will be in alloc.h. To use these 4 functions, you need to include stdlib.h, or in case of Turbo C compiler, you need to include alloc.h header file. Now, calloc is used for creating memory space dynamically. It generally creates memory space in contiguous block. Each and every block will be of same size. The size of the each and every block will be same as the data type you are mentioning at the function call. It creates the space as mentioned size and return the starting address of the created space. So it is returning an address, means it should be some kind of pointer, and it is basically a void pointer. To use this space, we need to typecast this void pointer or the returned address into our desired data type. So if we want to use that space as an integer, then we need to typecast it as an integer pointer. Now, general way of calling a calloc function is given like that. So here we are going to mention our desired data type, and as it is a pointer, so pointer operator, then the function name calloc, and it takes two input argument. N is the number of block it will create, and this size defines the size of each block. Not only that, it initializes each block by 0 value. So we are going to see an example of this one. Suppose P is an integer type of pointer. Now in this calloc function, n value is 5 and each and every block will have a size of an integer. So considering integer size as a 4 byte, so each and every block will be of 4 byte, right? So totally it is creating is 5 into 4, 20 byte of space, and and there will be 5 blocks and each and every block will be of 4 byte. As we already know that calloc initialize each block by 0 value, so each and every block will be initialized to 0. Now here in this diagram, assume that the starting address is 2000. So starting address is 2000, that will be returned by the calloc function. So this 2000 value will be returned by the calloc function, but as a void pointer, right? Now, a void pointer is that pointer which have a particular memory address but does not have any defined data type. So to use a void pointer, we need to typecast it. So we are going to use this create a space as an integer array. So we are converting it, or we are typecasting it by integer pointer. So this 2000 will now be a integer pointer. As it is an integer pointer, we can store it into P. So in this case, P will have the value 2000. So that is how we can create an array using calloc function. Remember, here it is not necessary that we are creating a block of creating each block as a size of integer, so we need to convert it into a or we need to typecast it into a integer type of pointer. Depending on the this and this may not be same. So you are creating 5 blocks of space of integer size, but you are converting into a floating type of pointer. That time each and every block will be of size of a floating type of variable, right? Now, for example, if I am creating this one, but we are typecasting as a character pointer and storing into a character pointer, that time each and every block, there will be 20 blocks, and each and every block will be of 1 byte. So basically this will create initial cells, but final cell size will be determined by the typecasting only, depending on the typecasting. So as we have already discussed, we will return the starting address of the first block as void pointer. So it is returned 2000 as a void pointer, which is typecasted to integer pointer. Here we are typecasting into an integer pointer. P is holding the address, and by this we can by using P we can access all the elements of the created space. So P is holding the address, and by P or using P we can access all the elements in the created space. So basically you can see that we are creating an array of size 5 integer type. We are creating an integer array of size 5 dynamically by this notation, right? We are going to see it in a practical example. Next, we are going to discuss about the malloc function. Malloc function is also used for creating a creating a memory space dynamically, means at the runtime, but instead of creating space in blocks, it create a memory space in bulk. Create a space as mentioned size, it will create the space as mentioned size and return the starting address of the created space as a void pointer. This point is similar to the calloc function, but it creates a space in bulk and calloc creates a space in blocks or cells. Now to use that create a space, bulk space, we need to typecast it. The return address should be typecast, and generally we call the calloc function by this notation. Here we are typecasting it into our desired data type, then we are calling the calloc function which will return a void type of pointer and n into size of the data type. So it will create a bulk space of n into size of data type. The size of data type is 4, so it will create n into 4 byte of space as a block. Now initialize that bulk space by a garbage value. So it does not initialize the space by 0 value. So let us take an example and see how it is working. So here you can see that we have an integer type of pointer, and instead of creating the space by using calloc, here we are creating the space as malloc. Now in the malloc function, it will take only one input argument, and that is the, as it is creating the space in bulk, so it will be the size of the total space. Here we are mentioning 5 into size of integer, as our integer is of 4 bytes, so it will create a total space of 20 byte, and this is a 20 byte of space, and it will return the starting address of the bulk space. So let us take that starting address of the bulk space is 2000. So it will return 2000 and it will return it as a void pointer. Now as it is returning the void pointer, we need to typecast it into our desired data type for using that. So we are typecasting it into an integer type of pointer and putting into P. When you are typecasting it, this 20 byte of space will be divided into 5 blocks of 4 byte of space, because we are typecasting into integer type. Now if we typecast it into a character type of pointer, then this 20 byte of space will be divided into 20 blocks or cell of 1 byte, because a character will take 1 byte of space only. So the division of this block will be depend on the data type in which you are typecasting, right? So as we have already told you, it will create a bulk memory space of 20 byte. It will return the starting address. Here the starting address is 2000, and to use it we are typecasting into an integer type of pointer. After typecasting, it will divide the space of the size same as typecasted data type. So here we are typecasting into integer, so each of the block will be of integer size. So there will be 5 blocks and each of the block will be of 4 bytes. Now P is holding the starting address of that block. So using P we can access all the elements of the created space. Now calloc and malloc generally create the memory space. Calloc creates space in cells, where malloc creates space in bulk or mass. So here the difference is that when we are going to use the calloc and when we are going to use the malloc function. When we are going to create array dynamically, we simply go for the calloc function. But when you are creating any user defined variable space, we go for the malloc function. The malloc function will be mainly used in case of creating data structure like linked list, double linked list, queue using linked list, stack using linked list. For those kind of thing we are going to use for malloc, but if our purpose is to create space for array, we go for calloc function. So now let us compare the calloc and the malloc function. Calloc function, it is you can see that here it will take two input argument. One is the number of blocks or number of cells it is going to create, and the size of each and every cells. Where the malloc function takes only one input argument because it is creating the space in bulk or mass, and it will be created a total of that size. Now it takes two input argument of integer type, where else the malloc here the input argument should be of integer type, and here the malloc function take only one integer input argument. Why all the parameters will be integer? Because the numbers of block will be integer and the size of each block will be integer in case of calloc function. For malloc function, obviously the size cannot be a fraction, so the input argument will be of integer type. It creates space in blocks, it creates space in bulk. Fourth point is it initializes the created space by zero value, where else the malloc function initialize the created space by garbage value. Similarity between these two is it returns a void pointer. It is also returns a void pointer. It will point to the starting address of the created space in both of the calloc and the malloc function. So let us take an example where we are going to create a memory space, going to create an array using the calloc function. Means we are going to create an array at the runtime. So you can see that P is an integer type of pointer and C is I and C are two integer type of variable. Here we are asking from the user to enter the numbers of cell it is going to create. So in calloc function the n will be C because we are going to create n numbers C numbers of cell, and as we are going to create an integer type of array, we are mentioning that the size of the each cell of will be of integer. Now remember, this is for your reference only. It will be decided when we are typecasting it into a integer type of pointer. So P is an integer type of pointer. Calloc function is returning a void type of pointer. We want to create an integer type of array. So we are creating or we are typecasting it into a integer type of pointer. So starting address is for this statement will become a integer type of pointer, which can be easily stored in a integer pointer P. Now this part we have already discussed. Here we are using P using the array notation, and how we can use this is discussed in our discussion with the pointers. So similarly we can access each and every element of that P dynamically created space pointed by P using the array notation. For understanding this, I recommend you to go for our discussion on the pointers where we have implemented array using pointers. So let us compile this code and run it. So it is asking for number of cell I want to create. Suppose I want to create 6 cells. Then it will ask for the array element. Let us take, I am giving 1, 2, 3, 4, 5 and 6. So you can see that we are accessing the array elements by using the starting address of the dynamically created array, which is stored in P. Now let us take how we can access, let us discuss how we can use this concept for dynamically creating a two-dimensional array. We are going to create a two-dimensional integer array. For this, let us understand this diagram. Here, Q is a dynamically created array of, here there are two cells in it, right? Now Q is not an integer type of array. Q is a array of integer pointer, right? So it can store the address. Now its size is 2. Now so it means that it can store the address of two integer variable. It can store two integer pointers, right? Now its starting address is 5000. Now here we are creating space dynamically for three cells. Each and every cells will be of same size as integer because we are creating a integer type of array. Now we are typecasting a starting address, that is 1000 into integer. So we are typecasting it into a integer type of pointer. Similarly, we are typecasting it into a integer type of pointer. Now, as Q is an array of pointer of integer type, so we can put this 1000 over here, right? Now we can put the 2000 over here. Remember, this one and this one are created dynamically. Similarly, Q is also created dynamically. So this creation will give me the numbers of, this will give me each and every row, and we are putting the each address of the each and every row in the dynamically created Q array. So if I write Q0, so in this will point to this location, and if I write Q1, this will point to this location. Now using this concept, we are going to implement a two-dimensional array by dynamic memory allocation. So let us see that code, how we can do that. So here you can see that Q is a double pointer, means it can store the address of another integer type of pointer. Here we are asking the numbers of row we want to create and numbers of column we want to create. By this statement, we are going to create the rows for the dynamic two-dimensional array. Now we are typecasting it into a double pointer of integer type and putting into Q. So we are basically doing this part of the code by that statement. Next, we are creating the rows in loop depending on the numbers of row we want to create, and putting each and every starting address of the row into the Q array. So we are performing this assignment by this loop. So finally, after these two operations, we are going to create this memory allocation, or this we have implemented this concept. Now as we have implemented this concept, now by simply using the two-dimensional concept of two-dimensional array, we can access each and every element. Now we know that how we are going to put some data into two-dimensional array, and how we can access the data from the two-dimensional array. Remember, here we have taken the row and the column number from the user. So depending on that, we have created the two-dimensional array using this concept. We have created the two-dimensional array dynamically. So let us compile and run this code. So it is asking for the numbers of rows. Suppose I am giving 2 and numbers of column is 3. So each row will have 3 columns and there will be 2 rows like that. Now it is asking for data. Let me put 6, 5, 4, 3, 2 and 1. So A00 means Q00 will have 6 value. Similarly, Q12 will have 1 value. So you can see that we have created a two-dimensional array by implementing this concept and using dynamic memory allocation. So as we are creating array, we know that calloc function is better for creating array dynamically. So we have used the calloc function. You can simply do that thing using the malloc function also. Instead of r, you will put multiplication over here, and here you will have to put multiplication, and instead of calloc the function will be malloc. Both of the code will do the same thing. So let us come to the next function, which is realloc. Realloc is used to reallocation of the dynamically allocated space. If we want to create if we want to add some space or deduct some space from the allocated space, that can be done using the realloc function. It takes two input arguments. First one is the pointer to the dynamically allocated space, and the second one is the new size. P is the dynamically created space. Now we want to reduce the size of the dynamically created space, so we mention it 6. So from 20 it will be of 6 byte. That is the purpose of the realloc function. Remember, realloc function can be used only on the dynamically created space. At the time, static created space cannot be reallocated or resized using the realloc function. The last function for dynamically memory allocation is the free function. It is used to delete a dynamically allocated memory space. Means the space is created on the main memory, and when its utilization is over, there is no need to keep it in the main memory and occupying that main memory. We can remove it. How can we remove it? A dynamically allocated space can be removed using the free function. It takes only one input argument, that is the pointer to the dynamically created space. So if we use P, and P is defined by this, then it will remove or delete this dynamically created space from the main memory, right? So there are four functions: calloc, malloc, realloc, and free, to use or utilize the memory space in more efficient way by creating it dynamically, resizing it dynamically, and deleting it when the space is not required. So that's it from dynamic memory allocation. Practice this kind of problem and see you in the next video. Thank you.